and start with a quiz. Last time I asked you to try to match the graph with the actual equation, and some people did it perfectly fine. This kind of exercise is very popular in this textbook. They give equations and they want to find their graphs among those provided. And of course, to find the graph, you should graph it first, because when you look at those graphs, they all look very similar, of course. So guessing is not, I guess, the way to go. So let me find it. We had section 6.4, so let me get to the end of it. So I just clicked on 6.5 to get faster. So I hope you all have textbook by now saved. So this way you get quicker to the page you need. So almost there. Okay, so that looks a little bit familiar. And we had been working with, I believe, exercise 22, right? Exercise 22. Good morning. So our plan is to decide on a graph for 22. And to be able to decide on that graph, I need to actually think of its graphing. First of all, I noticed that 2 is a magnitude. Well, pretty much in all problems here, either it's 2 or 3. So what I'd like to do is a little bit of preparation, put pi over 2x in between of 0 and 2 pi. This is standard. And once I did that, I need to pull out x by taking a reciprocal, put 2 over pi, so it cancels with pi over 2. So I need to have a clean letter x, and then we have these two canceled. So left side is going to be 0, because times any number, it's still 0. Pi's will cancel, we get 4. So I need to find 4. So basically, here's my graph. I don't really need to produce a picture. I just want to see that's a cosine. So we start at some place on the y-axis, go down, and then bring it back up. And the amplitude is 2, and the 4 is our period. So now I need to find something that matches. So definitely not with those 2 pi's. I just need one that starts at a 2 and then ends at a 4 and hangs in between, and looks like this is piece that I see in here. So we have the answer. So the key idea, graph it first, because if you look at those graphs, how can you guess, right? So if you would like over weekend to do another problem like that, you're welcome to do as many as you like. You're always welcome to send it to me and to let me know that this is your extra credit. So I'll be more than happy to give you extra points. So this section, as well as the next one, they just keep on graphing. So let me do another problem here, number, how about say 57. The little extra at the end, little extra has plus 1/2, and now it's a function cosine again, but this function cosine has negative 3/2 in front. And because of that negative 3 over 2, my graph is going to be not starting at positive, but at negative place, and we'll have a little like a flipped structure with it. So we get also function cosine, but now it starts on the bottom and goes up because of the negative multiplied by it. In fact, since it's a negative 3/2, I just put it here, as well as the maximum is also going to be 3/2. Now, pi over 4x. So it's automatic. I put it in between 0 and 2 pi, right? So I will be able to pull the period from this. So 4 on the top and pi on the bottom. So we get just a clean letter x, right? And that's great. So I put 4 over pi then. And then I'll be able to see that my x is in between of 0 and looks like number 8, right? Because 2 times 4 is 8. Okay, 8 is here. What else? 1/2. Notice there are no graphs here, but we will actually bring this by 1/2 upwards. So I'm gonna move this up a little bit. And now I'm gonna make a separate picture so we don't have too much mess. So it looks like I already have 8 here. Now the lowest level will be -1 because we bring this up by 1/2, right? 3/2 and 1, it'll be -2/2 or -1. And on the top will be 2. So the graphs that we need will still match this cosine loop, but starts at -1 and going up to 2. And I clearly marked 8 on the right side, and I put some more of it like that. So key part, amplitude numbers, the amplitude numbers such as a 2 and -1, and also 8. So I suggest that you try to redo this exercise again yourself, and if you feel like you can do 55, for example. And I'll move to the next section that just does more of this. It doesn't really do anything extra, but it introduces you with a few more graphs of functions called other trig functions, such as a tangent, cotangent, and so forth. I think today I'll just look at the tangent and cotangent because, again, overloading you with too many functions is not a good idea. Because I think tangent function is another very popular graph that we definitely gonna see a lot. So the tangent function is also produced by taking so-called main piece, and this main piece happens to be in between of negative and positive pi over 2, and it actually has a pair of vertical asymptotes, and that's what they actually show us here. So if I take a piece in between negative and positive pi over 2, so this will be the piece here, and it will repeat to the left and to the right. Again, should repeat infinitely many times, but we'll repeat it just a few times. I say, why this is a main piece, not that? It technically doesn't matter, but we like in between negative and positive pi over 2 because we need to be kind of uniform on where we start. And then once we know how to graph it, then we repeat it a few times, and that's all it is. So function tangent is having horizontal asymptotes simply because it's a sine over cosine, simply because we have a denominator And if you remember from college algebra, whenever you have 0 of denominator, that gives us a vertical asymptote. You don't have to remember that, you just should be familiar with the graph. So they graph various transformations of function tangent. Like here, for example, they put it twice. And when you double it, well, nothing really happens with a graph when you double it, just like if you ever saw the graph of x squared, and with respect to it, 2 times x squared. So if you multiply x squared by 2, the graph does not really change its shape. But what people say, from every point on x-axis, the distance to it doubles, so it gets a little bit skinnier. I guess that's the idea. So you have twice that much. So similar to the graph of function tangent, it's still in the same shape, but it's a little bit farther away from your x-axis, but it doesn't really change its shape, and that's why whenever you multiply by positive numbers, we basically keep the graph the same. If you multiply by negative, the graph flips, but positive, it just stays the same. So that's analogies. So that's why I don't really pay much attention to what's happening. The only thing in here is subtracting 1. So your tangent now is going to be moved down 1 unit. So it used to pass through the origin point. Now it passes through point -1. So the picture shifted down, just like we did in this section that we just looked at in 6.4. So let me graph some of the tangents. Today I'd like to graph some tangents, and next time I will look at the other guys, such as secants and cosecants. So today I'd like to graph a couple of tangents, and also then at the end introduce you with a cotangent, which is kind of similar to the tangent. I think those are important graphs to know for those people that plan to take calculus classes. The reason is that we're gonna produce so-called inverse functions. Inverse to sine will be arcsine. Inverse to cosine will be arc cosine. So there are 6 trig functions, and there are 6 their inverses. And it turns out those inverses, they do, especially in the calculus 2 exercises, there are some sections that deal with those inverse functions, derivatives, antiderivatives. So there's quite a bit of work being done with those inverse functions, and it's important to know their graphs to be able to do those problems correctly. If you don't plan to take calculus, then you don't need to worry about this. I'm not going to make an emphasis on that, but I will be talking about them because I know that for those students that plan to do more math is important. Because if you never saw arc functions and you're taking calc 2, then you will be in trouble. That's why I will be talking about that. And it's not hard. It's just something that we need to be, I guess, see once, and then when you see it again, I'll make sure you'll see it again, and then in the next class, when you see it again, I'm sure you're gonna start to like them, because there's really nothing challenging. They're all similar to functions, sine and cosine, and that's what my goal is, to show you them. So for a tangent function, we already saw that it's in between of negative pi over 2 and positive pi over 2. So it has its own specific, turns out. So what I need to do is put in between of this plus minus pi over 2. Guess what? Whatever the argument is. So it's whatever is in here, pi over 2x. Because my goal is always to pull out x, right? So what I need is the 2 over pi to go away. Okay, so I'm going to multiply by 2 over pi my thesis of this little inequality. So on the left side, I get -1. And then we have x in the center. And we have also number 1 on the right. And that's it. I'm ready to graph my function tangent, but now it's from -1 to +1 for the asymptotes perspective. So there I have one piece goes up, the other piece that goes down. So now we have this function tangent with asymptotes, so I can put a little bit more of it, of course. And we're done with the graph. So all that I really need to pay close attention to is going to be those asymptotes, what happened to them. Once I decided what happened to them, then we feel good and we have a result. Let's get another tangent. I see exercise 37 here. If you see another tangent, let me know, we'll graph it. But technically, graph a couple of them, you already know pretty much what is happening here. So it's a half that I don't really pay much attention to. Whatever's in front of function tangent, it's just not changing its shape unless it's negative, right? So it's quarter times x. So I don't put that +1 for now. I'm gonna be shifting. Oh, sorry, that's -2, right? So I'm gonna be shifting by 2 units down on the next stage. At this stage, I just wanna have a quarter x in between of, and that's something to remember. So it's from pi over 2 to negative to positive pi over 2. So this is a quarter, so I need to multiply by 4 to get x. It doesn't matter for us what number we multiply this by, we'll see what comes out. So this is a 2 pi on the left side, -2 pi. And x is in the center, and looks like +2 pi is on the right. Great. So here's my pair of asymptotes. It's actually all the same. So it's pi over 2 or 2 pi and 2 pi. So what's 2 pi? Well, that's 3 times 2, which is 626, something like that. So that's our function that, again, is in between of these asymptotes, so somehow goes like that. Again, the fact we have 1/2 in front, well, makes the graph get a little bit closer to the x-axis, just sit closer on it, and other than that, that's all. So now it's time to get the graph that we need with a -2 at the end, right? So what's gonna change now? Well, the change is that the graph is gonna fall down to -2 level. So it's gonna be sitting here at -2. Everything else is the same. So the asymptotes gonna stay the same. So the graph of this tangent-like hyperbola-like function, notice it's not really hyperbola because it's actually having the asymptotes, right? So this bunch of these blue pieces is green or here. So I'm not gonna copy this. This is right here. So that's our result. So function tangent. Function tangent, again, good to be familiar with, because it also has a friend. As I said, I will show you function cotangent today at the end. I'm gonna stop because I don't want to put too much on it on you. In fact, I think we're going in a good shape in terms of covering this material, so we're good. And I will just give you the graph of function cotangent. Turns out it's analogous to tangent. It also has vertical asymptotes. But the function cotangent is going to be decreasing. So it kind of goes down. Passes here through whatever's in the middle, pi over 2. And of course, there are more of it. There are left, more on the left and on the right. This will be your pieces. So the vertical asymptotes, there are multiples of pi. And that's why people say the period of those functions equal to pi. They repeat themselves every pi, not 2 pi as sines and cosines. Again, if you decide to double check, you can actually see how they did it. I think they did a pretty good job here at the beginning of this little section. They say the cotangent is a cosine over sine. So when you have a sine in your denominator, then denominator gives you zeros. I just skipped that. It's a nice graph here. So you see that zeros of function sine actually is what I consider to get those asymptotes. So if you get this sine in denominator, then its zeros will be at multiples of pi, and that's exactly where we have those asymptotes. So that's actually what they have here. And they put a bunch of calculations in the table and connect points and get the results. I think today I'll just let you go without a quiz. I think it's been a lot, and the material is very, I guess, concentrated in here. So I want you to do a couple of problems, and I think it's good enough because they're all really same. And I can do one more exercise with a cotangent for you, of course, and leave out those secant and cosecant for the next time, because they all have like a special type of specifics. So let me try one number.
Professor,
38, for example. I'll do 38 and I'll let you go because I think you deserve a break and I'm not going to give you a quiz. You had a quiz already last time, right? So
wait, Professor, I have a question.
I think you're doing pretty good. Those people that didn't have a chance to take a quiz, well, then take it. Take it. I sent you lecture recordings. Again, for those that didn't have a chance, because some people start panicking and say, Alex, I already took. Well, if you took it, good, then don't worry. I'm just talking for those that did not take it. So 38, cotangent function, and we multiplied by 3, which we already know does not really make much difference. Yes, please ask question. You can ask out loud. Or sorry, I think I have mute. My computer is on mute. Okay, you can talk now because I didn't hear.
Oh, a student had a question, but I don't know where they went.
Could you please ask it again? Do you have a question? Yes, please ask. I didn't understand. Sorry. We can talk at the end of class because I'm not sure what question is. If you have some particular exercise in mind, just let me know. So anyways, I'm doing problem 38. In the problem 38, again, I see that -2 at the end that will utilize a little later. So for now, I just trying to graph function cotangent, and the graph of function cotangent should resemble the one we have on the right side, but now I need to put a half x for its argument, and it's in between of 0 and pi, because what I want to do is graph just one branch here. It looks like that. So what questions we have to do? Same problems that I do in class. Same problems that I do in class. So it's always the same thing. So you do problems in class, that's same for homework. So I guess that keeps it straightforward, I hope. So anyways, multiplying by 2, right? Multiplying by 2 everywhere. Like that. So you get a 0 still on the left side. X is my goal, to have a clean X, and now it's 2 pi. And this feels good, because now we know what the asymptotes are. There are multiples of 2 pi. I see they used to be pi, so now it's 2 pi. Yeah, so what? Just put instead of pi, 2 pi. Like that. If you like, you can put 4 pi or -2 pi. But the point of story is now we need to get a tangent. Oh, sorry, cotangent. 3 times cotangent. So in between will be here, and it will go down and up. That's your cotangent without -2. So give it -2. Bring this down, right, by 2 units. So what's going to happen now? Well, -2 will be here. That will be the point. So I carefully put this same asymptotes, pi over 2, and now the tangent looks like that. So do same problems that done in classes, same. You don't have to do different, you do same is good enough. You like different, do different. It's your choice. But do something. That's the idea for the homework, so you should always, well, practice a little bit, and the day of the midterm is coming. It'd be like a first week of October, right? So next week I'm going to discuss it in very detail, what be for the midterm and everything. So you will be aware, of course, what's for the midterm, because I plan to send you practice midterm. It'd be just a couple of exercises, not a lot. And then I will do it for you also, so you will have no surprises. You will know for sure what's for the midterm. And up to now, just look at these same exercises and do them little by little, do them. And when the time comes, I will, of course, remind you to email me your work, whatever you are doing now outside of class. Eventually, you should send to me by email. And don't put it on Canvas. I know some people really like to put something on Canvas, and I cannot see it. That's the Canvas. Don't put anything there. Email me. I will tell you that. So no worries. So question is, do we graph? Yes, that's what I do. Don't I? So Alex, are you sure? Well, this thing called graph. Made a picture, right? That's graph. That's the answer for the exercise. So what's important to have is clearly marked asymptotes and clearly marked points that you actually shifted this down. So it all has to be on the picture, on the graph. So yes, of course, we graph. So I'm gonna let you go. Today, no quiz, and it's Thursday. I'm sure you need a break, right? It's weekend coming. You deserve it. Nice weather, so it's not hot. You really need to have a good time, right? So please have a good time. So the homework, what's for homework? Same problems done in class. Same, exactly the same. They say, what does that mean, the same? Well, look at what I did. You see, problem 38, do 38. That's all. I did another one before. So a couple of problems, good enough. A couple of problems will be fine, okay? So you should take it easy. It's all there. It's all in a recording, I record. So if you forgot, just check your email. I'll send you email in a couple of hours. I send it in the afternoon because it takes a while.